Okay, today we're going to talk about graphing quadratics. I can talk, really. Remember, quadratics look like this. They're usually a function. They look like that. They should always be a function, actually. They look like that with the ax squared plus bx plus c form. And here are some facts about graphing that you're going to have to know. And we're going to use these facts now to graph something over there. Now, and I'm going to graph it in blue and find out my information in blue. But I'm not going to start up here, although these facts will become first later on. Right now, they're not going to make much sense. So I'm going to start down here, and then we'll work our way up. So right here at making an XYT chart. See, you never knew those things were going to come back, did you? So if I want to do an XYT chart, we know it has to look like that. But part of that is that I have to make sure that it is around this particular x, my negative b over 2a. That's the best place to start whenever you're graphing any quadratic. So I'm going to come over here and figure out what negative b over 2a would be. Opposite of b is a positive 4 over 2 times 1, which is going to equal 2. So I need to let my x be 2. Oh, it's not x, just a 2. In addition to the 2, I want to do 2 numbers to the right and 2 numbers to the left. So this is my 2. This is my 2. 2 numbers to the right make it 3 and 4. And 2 numbers to the left would be 1 and 0. You have to start wherever that is, because that'll tell you where the middle of your quadratic is. And since a quadratic is a curve, you need to know where the middle of it is. So the middle is going to be here, which means this is on one side and that side is the other side of it. And that's okay. Right now, we don't know anything else about what it's going to look like, except the middle is located around here. So now I need to take the 2 and plug it in for my x and see what I get out for my y. So 2 squared is 4. I'm going to write them up here real quick. And then 4 minus 4 times 2 gives me 8 plus 5. 4 minus 8 is negative 4, plus 5 is a positive 1. Okay, that's one of them down. Now let's do it for 3. 3 squared is 9, minus 4 times 3 is 12, plus 5. 9 minus 12 is negative 3, plus 5 is a positive 2. Okay. Now let's do it for 4. 4 squared is 16, minus 4 times 4 is 8. Oh, sorry, 4 times 4 is 16 too. Plus 5 gives me 5. Okay, now let's go and do it for 1. 1 squared is 1, minus 4 times 1 is 4. Plus 5, that's negative 3, plus 5 is a positive 2. Okay, one more. 0 squared is 0, 4 times 0 is 0, plus 5 gives me 5. Okay, so I've done my XYT chart, and now I can go ahead and graph these points. 2, 1 is there. 3, 2 is right there. 4, 5. 1, 2, 3, 4, 5 is right there. 1, 2 and then 0, 2, 3, 4, 5. And you can see it's got a little dip to it. Looks like a little dip. And we know that this is the center of it. Now, a lot of people want to make this into a V, but it's not a V. It's more of a U. There's a little bit of a curve going on there. It's not a straight up and down. They aren't straight lines, they're curved lines. So you kind of make sure that it's nice and rounded kind of at the bottom to give you that nice curve. They might get kind of tight, so it might be hard to make that little round down at the bottom, but you need to try. So I've graphed my quadratic, and it's going to keep on going that way. That's what the arrow is for, and it's going to keep on going this way. That's what that arrow is for. So it has been graphed. We used the XYT chart. To graph the equation. Using 2 points on each side of the vertex. Now they threw in this nice line here called a vertex. That is actually the very center of your graph. That point right there is my vertex. So if they ask you what a vertex is, then you should be able to say vertex equals the point 2, 1. Because that's how you write a vertex. You say whatever the point is that it's at. Now the vertex isn't always the very bottom of the graph. Sometimes the graph, instead of looking like a U like this one, will look like an N. It'll be upside down. And when that happens, the vertex is at the very top of the graph. But you still use this method to plot the points. It'll have the look like it's going up and then down, just like this one had a look like it was going down and then up. Now, some tips to help you. We've made the XYT chart and we've made it around our x equals negative b over 2a. That negative b over 2a is what told us the first number in our vertex up there when we did it. It tells you what the first number is, the x coordinate for your vertex. So that makes it very useful. Every single parabola that we do, that's what these are called, parabolas. That's what this shape is called. Every single parabola that we do has something called an axis of symmetry. That's the very center of it, where if we folded along that axis of symmetry, it would be exactly the same on the right as it is on the left. That's why our numbers ended up repeating on each side. Our axis of symmetry is always right down the middle. And since that's the axis of symmetry, so if I were to fold it together, you'd see it matched up. Since our axis of symmetry is right here, that's the equation of that line has to be an x equals equation because it's a vertical line. So our equation for our axis of symmetry, that's how we abbreviate it, AOS, is going to be x equals 2, just like we got up there. It's the same stuff that we use. So that explains about the axis of symmetry. Now, let's talk about the stuff that's up at the top. Up here, you get these two notes, things about A. So if we're talking about A being greater than 0, in other words, if the number in front of X is going to be bigger than 0, then we always end up with a U shape, like we did, because 1 is what our A was, and it was bigger than 0. And that means that our vertex is the bottom, which was this point. So that's good. And it's called a minimum. When it's on the bottom, they call it a minimum, because that's as low as it'll go. If you happen to get one where the A is less than 0, in other words, if it's a negative x squared, then it's going to look like an N, and the point at the very top, which is still the vertex, is going to be known as your maximum, because it'll never go any higher than that. So you have to read the directions very carefully to find out if they're asking you for a minimum or a maximum, if they're asking you what the vertex is, if they're asking you to graph it, or to find the axis of symmetry, because you have to make sure you tell them exactly what it is they asked for. Telling them extra stuff isn't always bad. Telling them things or not telling them things that they're asking for, very bad. So make sure you tell them what it is they want to know. So if they ask for the axis of symmetry, make sure you always put the x in it, because that's the equation, x equals 2. If they ask for the vertex, make sure you find the negative b over 2a, and then plug it into the XYT chart to find out what the y is going to be. If they ask you to graph it, make sure you do your XYT chart. Always start with your negative b over 2a. That'll give you your starting point, and then you go 2 to the right and 2 to the left of whatever that starting point is. Okay. Some of these, they just asked you if it opened up or down, and if it has a max or a min. If that's the case, this one opens up because it's open at the top, so it opens up. This one would open down because it's open at the bottom, so it opens down. And it's a minimum if it opens up, and it's a maximum if it opens down. Some of them ask for you to state whether the parabola opens upward or downward, and if it has a maximum or minimum point. They didn't ask what that maximum or minimum was. They just wanted you to use that information. Some of them say to find the vertex, the axis of symmetry, and the x-intercepts. X-intercepts? Wait a minute. We didn't have any x-intercepts. No, you don't always have x-intercepts. But if you do have x-intercepts, then you need to find them. So let's do one where we have some x-intercepts, and that way we'll be able to find them. Okay, we're going to try problem number 28. Haven't done this one yet. We'll see what it looks like. So when you get one like this, it's not in this form. I don't know if you noticed that or not, but it's not in that form. And if it's not in that form, I've got to put it in that form before I can use all of this, which was quite handy in the last one. So in order for me to get it in that form, I'm going to go ahead and multiply this out. So we know that's really x plus 4 times x plus 4, which is going to give me x squared plus 8x plus 8, oh sorry, I'm doing stuff in my head again, plus 4x plus 16 So x squared plus 8x plus 16. But I don't want to take up all that space for it. So I'm going to back all this stuff up and just change it so that it says f of x is equal to x squared plus 8x plus 16 minus 3. But wait, we can do 16 minus 3. 16 minus 3 is just 13. So we get that. Okay. Going to be a little bit harder than I wanted it to be. All right. I take that back. I want us to do 26. I know I don't normally do that, but I told you I hadn't looked at it yet. I want us to do 26. 26 is easier, and I can make another point 26 that I can make 28. Just go ahead and erase it. You'll be all right. We still have one of those. Okay, so we're still going to have to multiply it out just like before. I just wanted it to be prettier. I'll do this one. We'll do another one after this one. Okay, so we have this. When I multiply it out, instead of it being x plus 3, we're going to end up with x plus 3 times x plus 3, which ends up being x squared plus 6x plus 9. Now, we know we have to do an XYT chart. We know that our starting point has to be x equal to negative b over 2a. So that means x is going to equal negative 6 over 2, which is negative 3. So I have to do negative 3. And then this is our negative 3. So 2 to the right side would be negative 2 and negative 1. 2 to the left side would be negative 4 and negative 5. And since we know this already, we know that our axis of symmetry has to be x equals negative 3. Because that was one thing they asked us for. Plugging these things in, do my calculations in a slightly different color. Negative 3 squared is a positive 9, plus 6 times negative 3 is negative 18, plus 9, which gives us 0. Negative 2 squared is a positive 4, plus 6 times negative 2, that's negative 12, plus 9 gives us 1. Negative 1 squared is 1, plus 6 times negative 1 is negative 6, plus 9 gives us -2, +2. I don't buy that. +4. -5 and 9 is +4. And then -4 squared is 16 minus 24 plus 9. That's +1. And then -5 is 25 minus 30 plus 9. That's +4. But I need to expect that those two are going to repeat because they have to repeat. And just like we know looking at it, that it's going to be positive, so it has to be in a U shape, which means our vertex is at the bottom. And our vertex happens to be right there. So I can write that the vertex equals -3, 0. Because our vertex is always going to be wherever that is. And then -2, 1 is right there. And -1, 4 is up there. And -4, 1 and -5, 4. Yours doesn't have to be exact, but you notice I did round it down here. So it's not too much of a sharp V shape. Now, your book said to find the vertex. We did that. Find the axis of symmetry. We did that. Use each to graph the following equation. We did that. The only thing it asked for that we haven't said anything about yet is our x-intercepts. Our x-intercept is where it crosses or touches the x-axis. And this one only touches it in one spot. And that's at the point -3, 0. Now, your x-intercept is not always going to be your vertex. It just happens to be that in this case. Just because we multiply this out to make it look like this does not mean that all the ones that we multiply out are going to be positive. Sometimes they are negative. I promise. Okay, let's look at one more. One more. Okay, I think this is the one that I want. First of all, when you first look at it, I think you notice that it starts out with a negative. Bum, bum, bum. So we're finally going to do an N one, which means we're going to end up with a maximum. That's cool. New, but cool. We still start out the exact same way. We're still going to look for an XYT chart. And we have to find where our starting point is going to be. So we have to find our -b over 2a. Our -b makes it a +2 over 2 times -1, which makes it 2 over -2, which is just -1. So we know our axis of symmetry is going to have to be x is equal to -1. And I get to start at -1. So when I'm at -1 and I go 2 to the right, that's at 0 and 1. And when I go 2 to the left, that's -2 and -3. So those are the numbers I need to worry about. Okay? handle that. So -1, plugging it in. Let me do that in a different color. Plugging in -1, I get +1 minus 2 times -1 makes it a +2 plus 15. Oh, that's a big 18. I'm not sure it don't go up that high. Might have to change some things down here. Then for 0, minus 0 plus 15 gives me 15. Okay. And then for +1, +1 squared gives me 1, but there's a negative there, so that's -1. And then +1 times -2 gives me -2, and then plus 15. Which is 12, right? Wondering if I did that one right, because I just remembered about that just this second. So I'm going to go back and do that one. Maybe you caught my mistake, but you didn't holler loud enough. You should have hollered louder. I'm just saying, who cares if you wake people up? It's important. -1 squared is a +1, but that makes it a -1. And then minus -1 and a -2, make it a +2, and then a plus 15. And that's 17, 16. So, okay. I believe that better. Okay. I still don't have up to 16, but we'll see what I can do. And then -2 squared is +4. +4 with a negative is a -4. And then -2 times -2 is a +4, which gives me 15. I believe that 15 now, because we got it again. And then to check the 12, -3 squared is a +9, so that makes that a -9. And that'll be +6 plus 15. That's 21 minus 9. 12. So I believe that now. Okay. Enough scribbles. I can go ahead and start my graphing now. So -1, +16. I think I'd better number these by 2s. So that's -2, -4, -6, -8, which makes this +2, +4, +6, +8. And that can be 2, 4, 6, 8, 10, 12, 14, and 16 will be up there somewhere. So -1, 16, halfway, all the way up. And then 0, 15 is up there. And then 1, 12 is like right there. And then -2, 15, that's like right there. And -3, 12, that's like right there. Well, that's way up there. And small to see. But more importantly, it's heading down towards that x-axis. And we don't know where it's going to cross. Okay, let's go back to what we need to find. So for our vertex, we got that it was located at -1, 16. That's good. And we graphed it. We know that it's a maximum. So the only thing that we haven't done yet is find our x-intercepts, because we don't know where it crosses down here. Well, in order to find x-intercepts, back in the day, what we used to do is we used to say, let y equal 0 and solve for x. That was what we did. So up here, we know f of x is the same thing as y, so I'm going to let that be 0. That gives me -x squared minus 2x plus 15. If we're going to solve for x, we need to factor it. And the first thing we do in factoring is take out any GCF. We don't like having a negative there, so let's take it out. That's going to leave me with x squared plus 2x minus 15. Okay. Negative kind of falls away because it can't be 0. Two things that multiply together to give you 15 and subtract to give you 2. Well, I remember that being 5 and 3. So that's going to be a +5 and a -3. So that means that either x plus 5 is equal to 0 or x minus 3 is equal to 0. One of them's got to be 0, maybe both. So I subtract 5 and get x equals -5. And I add 3 and get x equals 3. So I have x equals -5 and x is equal to 3. Well, back in the day, we would always say that this really meant that it was the point -5, 0, because that's what we plugged in. And we would say that that was really the point 3, 0, because 0 is what we plugged in. Well, this is where 3, 0 is. And this is where -5, 0 is. Huh. So if I were to have extended this on down, it would have crossed right there. And if I were to have extended that on down, it would have crossed right there. Way back when we were factoring, we were really graphing x-intercepts. Because that's what we did. When we solved, we found x-intercepts. But then there were problems, I remember when we were factoring, that when we tried to solve, we couldn't factor. Then we learned the quadratic formula. We could do any of them. So I bet you could find the x-intercepts for any of these problems, even if they weren't pretty. Because you could always do the quadratic formula to find out what your x would be. It would end up being a nasty square root, and who wants to graph that? But you could stick that in your calculator and get a decimal for it. Huh. So even up here, when we were just looking at it, we could have factored it to get our x-intercepts. Instead of all this plugging stuff in. Huh. your x-intercepts come from factoring. I'm sorry, but I think that's pretty cool. You don't necessarily get them when you do that. But you might, because if we would have extended it, if we would have thought beyond just 2 on either side, eventually we would have gotten to the -5, 0. And eventually we would have gotten to the 3, 0. And then wait a minute. This is our axis of symmetry. This is 1, 2, 3, 4 spaces away. This is 1, 2, 3, 4 spaces away. It's always going to be even from your axis of symmetry. So really, if you wanted to, I suppose you could only find points on one side and then just copy over the answers for the other side, because they're always the same anyway. Wow. Dude, that's a lot. So these are your x-intercepts. I'm just saying that right there, that's pretty cool. Because you know, at one point in time, you were telling your mom, I remember hearing about it, you were telling your mom that it was so cool that it seemed like everything tied into everything else, except you can never tie the graphing in. It was like it stood alone, but now you find out it ties in too, to everything. It's like it's all one big ball of stuff. Wibbly wobbly, timey-wimey stuff. I couldn't help it, I saw the targets. Okay. We need to talk about classwork and homework. Because how could you not have it after all? I mean, really, did you see that? That's so cool. I think it's cool. You don't have to think it's cool. I think it's cool. I think it's really cool. Really. I've been so excited. Okay. I think it's cool. Okay, classwork and homework. Classwork. Page, 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 page. 560. Well, technically it's all on page 561. 13, 17, and 27. And then homework is numbers 15, 19, 25. I'm just saying, I think it's cool. You don't have to think it's cool. I understand if you don't think it's cool because, you know, I'm a geek that way. That's what I do. But darn, I think it's cool. Okay. Bye.